Have you ever wondered how solar thermal power plants generate electricity? Allow me to unravel this intriguing concept for you. Solar thermal power plants, also known as concentrated solar power systems, are indeed marvels of modern engineering. These powerhouses, quite literally, harness the energy of the sun, the most abundant energy source known to mankind, to produce electricity in a sustainable, clean, and environmentally friendly manner. Now, you might be asking, what exactly is a solar thermal power plant? In essence, it's an energy production system that uses sunlight as its primary fuel source. But it's not just any run-of-the-mill solar panel setup. These are large-scale operations, often covering vast tracts of land, designed to concentrate sunlight to produce high-temperature heat. This heat then drives a steam turbine connected to an electricity generator, and voila, we have electricity. The beauty of this system lies in its simplicity and efficiency. By using the sun's energy, we're tapping into a power source that's not only free and plentiful, but also renewable. We're not depleting any finite resources or causing pollution. We're simply taking what the universe generously offers us every day and converting it into a form that can power our homes, our industries, and our lives. The importance of solar thermal power plants in today's world cannot be overstated. As we grapple with the existential threat of climate change, the shift towards renewable energy sources has become critical. Solar thermal power plants, with their ability to provide large-scale, reliable, and clean electricity, are at the forefront of this energy revolution. We live in exciting times where the fusion of science, engineering, and environmental stewardship is paving the way for a brighter, cleaner, and more sustainable future. And solar thermal power plants are a shining beacon in this journey. Now let's delve into the fascinating process of how these power plants convert sunlight into electricity. The sun is a powerful source of energy, but how exactly do we harness its heat to produce electricity? Let's dive into the concept of solar thermal power. This is an intriguing process, one where we convert the abundant energy of the sun into usable electricity. It's not magic, it's science. Solar thermal power is all about heat. The sun, our nearest star, is a colossal furnace that's been burning for billions of years. It emits energy in the form of light and heat, which travel an impressive 93 million miles to reach Earth. This energy is free, limitless, and readily available. The challenge lies in harnessing it effectively. Here's where solar thermal power comes into play. The process involves absorbing sunlight to heat a fluid. This fluid, in turn, is used to generate steam, and that steam spins a turbine connected to an electricity generator. It's a chain reaction, a series of steps that convert solar energy into electricity. Think of it as a giant tea kettle. You put it on a stove, and the flame heats the water inside to create steam. The steam wants to escape, and in a solar thermal power plant, it gets funneled into a turbine, causing it to spin. The spinning turbine is connected to a generator, and voila, we have electricity. The fundamental principle here is the conversion of light energy into heat energy and then mechanical energy before finally transforming it into electrical energy. It's a fascinating journey from the heart of the sun to the power sockets in our homes. Solar thermal power plants operate on a grand scale, with vast fields of mirrors focusing sunlight onto a central tower or tubes filled with fluid. This concentrated sunlight heats the fluid, setting off our chain reaction to generate electricity. This is the basic concept of solar thermal power. It's a sustainable, renewable energy source that harnesses the power of the sun, turning it into electricity for our everyday use. With this understanding, we can now explore the step-by-step process of how a solar thermal power plant operates. The first step in generating electricity is all about soaking up the sun. In a solar thermal power plant, this task is entrusted to solar collectors, often called heliostats. These large, mirror-like structures are strategically positioned to catch and reflect sunlight. But it's not about just catching a tan. These heliostats have a vital role to play in our journey towards clean, renewable energy. Each heliostat is designed to track the sun's path across the sky, ensuring maximum exposure to sunlight throughout the day. Imagine a sunflower turning its head to follow the sun. absorbing as much light as possible. That's precisely what these heliostats do, but on a much grander scale. Now here's where it gets interesting. The sunlight reflected by these heliostats isn't just scattered aimlessly. Instead, it's focused onto a specific point, usually a large tower known as a solar receiver or a heat collector. The concentrated sunlight hitting this receiver produces an immense amount of heat, often reaching temperatures higher than 1,000 degrees Celsius. This heat isn't merely a byproduct, it's an essential part of the power generating process. You see, the receiver is filled with a heat transfer fluid, often a type of oil or molten salt. As the concentrated sunlight heats the receiver, this fluid also heats up. This heated fluid is then used to produce steam in the next step of the process. But let's not get ahead of ourselves. For now, let's appreciate the elegance of this first step. Using just sunlight and mirrors, we've managed to generate an incredible amount of heat. It's a testament to human ingenuity harnessing the power of the sun to fuel our modern world. So, we've soaked up the sun, we've concentrated its power, and we've generated heat. We've set the stage for the next steps in our solar thermal power journey. Having absorbed the sunlight, the next step is to use this heat to produce steam. With plenty of heat absorbed, it's time to create some steam. Now that we've captured the sun's energy and transformed it into heat, we need to convert this heat into steam. The process is pretty straightforward, but the science behind it is quite fascinating. In a solar thermal power plant, this heat isn't used directly. Instead, it's transferred to a fluid. This fluid is usually a type of oil or molten salt, chosen for its ability to retain and transfer heat effectively. The heated fluid then flows into a heat exchanger. So what's a heat exchanger? Well, imagine it as a hot plate in your kitchen. When you place a pot of water on a hot plate, the heat from the hot plate is transferred to the water, making it hot. In the same way, the heat exchanger in our power plant transfers the heat from the hot fluid to water. The water in the heat exchanger starts to heat up and eventually it reaches boiling point. When water boils, it transforms from a liquid state to a gaseous state, creating steam. This transformation is what we're after. The creation of steam is crucial because steam has a lot of potential energy. Now you might be wondering, why steam? Why not just use the hot water? Well, the answer lies in the properties of steam. Steam, being a gas, can expand and contract rapidly. This rapid expansion and contraction, known as the thermodynamic property of steam, makes it an excellent medium for transferring energy. This steam, full of potential energy, is then directed at high pressure towards the blades of a turbine. The force of the steam causes the turbine to spin, and the spinning motion of the turbine is what generates electricity. But we're getting ahead of ourselves. For now, let's focus on the steam. Our sun-soaked fluid has done its job, transferring its heat to the water, and the water has done its job, boiling and transforming into steam. The steam is now ready to be used to generate electricity, leading us to the next step. Now comes the exciting part, using the steam to generate electricity. Let's dive right into the heart of the action, where the steam we've generated in the previous step is put to work. This is where we convert all that thermal energy into mechanical energy, and then finally into electrical energy. So how does this happen? Well, the steam, which is under high pressure, is directed towards a turbine. The turbine is essentially a wheel with a series of blades attached. Think of the steam as a powerful gust of wind that is used to spin these blades. As the steam hits the blades of the turbine, it causes them to spin. This spinning motion is the mechanical energy we mentioned earlier. It's a bit like when you blow on a pinwheel and it starts to turn. Only in this case, the wind is steam and the pinwheel is a massive, highly engineered turbine. Now, this turbine is connected to a generator. What's a generator, you ask? Well, it's a clever bit of kit that can convert mechanical energy into electrical energy. The spinning motion of the turbine is used to turn a rotor inside the generator. This rotor is surrounded by a coil of wire, and as it turns, it creates a moving magnetic field. This moving magnetic field then induces an electric current in the wire. This is due to a fundamental law of physics called Faraday's law of electromagnetic induction. It's the same principle that's used in everything from bicycle dynamos to hydroelectric power stations. So, in a nutshell, the steam spins the turbine, The turbine spins the rotor creates a moving magnetic field, and this field induces an electric current in the wire. And voila, we have electricity. But remember, this is a continuous process. As long as the sun is shining and the steam is flowing, the turbine keeps spinning, and the generator keeps generating electricity. The turbine has done its job, but the process is not quite finished yet. So stay tuned as we move on to the final stages of our solar thermal power generating adventure. Having generated electricity, the next step is to make it usable. At this point in our solar thermal power generating journey, we've harnessed the sun's energy, created steam, and spun a turbine. But the electricity generated isn't quite ready for prime time. It needs to be converted into a form suitable for transmission and distribution. Electricity, as it's initially produced, is in a form known as alternating current. However, this current is at a low voltage, and low-voltage electricity isn't efficient for long-distance transmission. To tackle this challenge, we use a device known as a transformer. A transformer is essentially an electrical wizard. It can take the low-voltage alternating current and, like a magician with a rabbit and a hat, transform it into high-voltage electricity. This high-voltage current is more efficient for transmission over long distances. It's less susceptible to power loss, ensuring that more of the energy that's produced at the power plant makes it to its final destination. Once the electricity has been transformed to a high voltage, it's sent along transmission lines. These are the tall metal structures that you see crisscrossing the landscape. They form a network known as the power grid, an interconnected system that delivers electricity from producers to consumers. But the story doesn't end there. High voltage electricity is great for transmission, but it's not suitable for use in our homes and businesses. So when the electricity gets close to where it's going to be used, it goes through another transformation. This time, the voltage is stepped down, making it safe for use in everything from lighting our rooms to charging our phones. That's the journey of electricity from a solar thermal power plant to your home. It's a fascinating process that takes the power of the sun and transforms it into a form we can use every day. Now that the electricity is ready, it can be sent to the power grid and used to power our homes and businesses. So there you have it, the fascinating process of electricity generation in a solar thermal power plant. Let's take a stroll down memory lane and revisit our journey through the solar thermal power generating process. We began with the introduction to solar thermal power plants and the concept of solar thermal power. We learned how these plants are designed to harness the abundant energy of the sun, converting it into a form that powers our daily lives. Remember the first step? The process of electricity generation kicks off with the absorption of sunlight. Large mirrors, known as heliostats, track the sun across the sky, reflecting and focusing the sunlight onto a central receiver. This receiver, typically located at the top of a tower, absorbs the concentrated sunlight, converting it into heat. It's a crucial step, for it sets the stage for the subsequent stages. In the second step, this absorbed heat is put to work. It is used to heat a fluid, often a type of oil or molten salt, which then transfers its heat to water. This heat transfer process turns the water into steam. The generation of steam is an essential link in the chain, for it is the steam that drives the turbine in the next step. The third step involves the turbine being set into motion. The high-pressure steam generated in the previous step powers the turbine, spinning it at high speeds. The turbine is connected to a generator, and as it spins, it drives the generator to produce electricity. It is here that the energy of the sun is finally transformed into the electrical energy that we use in our homes and workplaces. The fourth and final step is the conversion and transmission of electricity. The electricity generated by the turbine-driven generator is transformed by a transformer, which increases its voltage to a level suitable for transmission over long distances. The electricity is then transmitted through power lines to our homes, schools, and workplaces, ready to power our devices and appliances. Throughout this process, we've seen the importance of each step and the role of solar thermal power in sustainable energy production. Solar thermal power plants provide a renewable and environmentally friendly way of generating electricity, reducing our reliance on fossil fuels and contributing to the fight against climate change. This journey from the sun to your home is more than just a fascinating process. It's a testament to human ingenuity and our ability to harness the natural world to meet our needs, without compromising the ability of future generations to meet their own. The next time you switch on a light or charge your phone, remember the incredible journey that electricity has taken from the sun to your home. And perhaps you'll appreciate a little more the true power of the sun and the remarkable technology that brings that power into our everyday lives.